YZ with a right angle at point Y. Inside the triangle, there is a segment, MN, where point M lies on the hypotenuse XZ and point N lies on the base YZ. We are given three important facts. First, MN is perpendicular to the hypotenuse XZ. Second, M is the midpoint of XZ, so XM equals MZ. Third, the length of XY is 6 units, and the length of YN is 4 units. Our goal is to find the exact area of triangle ZNM. Before we begin, if you enjoy learning geometry through clear, step-by-step explanations, make sure to like this video, subscribe to the channel, and let me know your answer in the comments before we reach the final result. Now, let's draw one additional line by joining point X to point N. This creates a new right triangle, triangle XYN. Notice that its legs are 6 and 4, so we can apply the Pythagorean theorem, which tells us that in any right triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. Therefore, xn squared equals 6 squared plus 4 squared. 6 squared is 36. 4 squared is 16, and adding them gives 52. Taking the square root of both sides, we get xn equals 2 times the square root of 13. Now, let's look at triangle XNZ. Pay close attention to an important geometric property. Since M is the midpoint of XZ and MN is perpendicular to XZ, the line MN is the perpendicular bisector of segment XZ. A point lying on the perpendicular bisector of a segment is always the same distance from both endpoints of that segment. Since point N lies on the perpendicular bisector, the distance from N to X must equal the distance from N to Z. That means xn equals NZ. We already found that xn equals 2 times the square root of 13, so nz is also 2 times the square root of 13. Now let's return to the large right triangle XYZ. Its vertical side is 6 units, and its base consists of 2 parts. The first part is yn, which is 4 units, and the second part is nz, which is 2 times the square root of 13. Therefore, yz equals 4 plus 2 times the square root of 13. Now we apply the Pythagorean theorem again to the large triangle. xz squared equals 6 squared plus the quantity 4 plus 2 times the square root of 13 whole squared. Let's expand that square carefully. Using the identity a plus b whole squared equals a squared plus 2 ab plus b squared. 4 squared is 16, 2 multiplied by 4, multiplied by 2 times. The square root of 13 gives 16 times the square root of 13. Finally, 2 times the square root of 13 whole squared equals 4 multiplied by 13, which is 52. Adding these terms together gives 68 plus 16 times the square root of 13. Therefore, xz squared equals 36 plus 68 plus 16 times the square root of 13, which simplifies to 100, 4 plus 16 times the square root of 13. Taking the square root, we obtain xz equals the square root of the quantity, 104 plus 16 times the square root of 13. Since m is the midpoint of the hypotenuse, the length mz is exactly half of xz. Therefore, mz equals 1/2 multiplied by the square root of the quantity, 104 plus 16 times the square root of 13. Now, let's focus on our target triangle ZNM. This is a right triangle because MN is perpendicular to XZ, and MZ lies along XZ. The hypotenuse is NZ, which is 2 times the square root of 13, and one leg is MZ, which we just found. To calculate the remaining side MN, we again use the Pythagorean theorem. MN squared equals the quantity, 2 times the square root of 13 whole squared, minus the quantity, 1/2, multiplied by the square root of the quantity, 104 plus 16, times the square root of 13 whole squared. The first term becomes 52. The second term becomes the quantity, 104 plus 16 times the square root of 13 divided by 4, which simplifies to 26 plus 4 times the square root of 13. Subtracting gives mn squared equals 26 minus 4 times the square root of 13. Taking the square root of both sides, we obtain mn equals the square root of the quantity 26 minus 4 times the square root of 13. Now, we are ready for the final step. The area of a right triangle is 1/2 multiplied by the base multiplied by the height. Here we use mz and mn as the perpendicular sides, so the area equals 1/2 multiplied by 1/2 multiplied by the square root of the quantity, 104 plus 16 times the square root of 13 multiplied by the square root of the quantity, 26 minus 4 times the square root of 13. Notice that the product of the two expressions inside the square roots is 1,664. Therefore, the area becomes 1/4 multiplied by the square root of 1,664. Since the square root of 1,664 is 8 times the square root of 26, dividing by 4 gives 2 times the square root of 26. So the exact area of triangle ZNM is 2 times the square root of 26 square units. That's a beautiful result obtained by combining the Pythagorean theorem with the properties of a perpendicular bisector. If you found this solution helpful, don't forget to like the video, subscribe for more challenging geometry problems, and leave a comment telling me whether you reached the same answer before the final step.